All right, everyone, engines revved and ready. Today, we're going deep, deep, deep into the world of the internal combustion engine. You know, the heart of most vehicles, the ICE. We've got this Wikipedia article, which I gotta say, it's way more interesting than I thought it'd be. So, ready to break it down and get our hands a little greasy.
Absolutely. And, even with all the talk about electric cars these days, the internal combustion engine, it's still running the show in so many ways, not just cars either, but think generators, power tools. So much of it still relies on this over 100-year-old tech.
It's kind of wild, right? Like, we're surrounded by these things, but how many of us actually know what's going on under the hood? So, back to question first. What, as an internal combustion engine, like, in a nutshell, what's the magic happening?
Well, magic might be pushing it, but it is pretty ingenious when you think about it. It's all about taking that chemical energy locked up in fuel, like gasoline, and through a very controlled series of mini explosions, turning it into mechanical energy.
Controlled explosions, you say. Thousands of them every minute. I'm suddenly feeling a little less confident in my car.
Well, it's a testament to engineering, for sure. And what's really fascinating is that the groundwork for all this, the basic principles, were figured out way back in the late 1800s.
Yeah, the article mentions names like Lenoir, Otto, Benz. Benz, obviously, I know from the cars, but who are these other guys?
Think of them as the founding fathers of the internal combustion engine. Lenoir, he gets credit for the first commercially viable one, but it was Otto who really refined the design with his four-stroke cycle. And then Benz, well, he's the one who took that engine and said, hey, let's put this on wheels.
So basically from workshops to the Autobahn, that's a legacy. Okay, so we've got these controlled explosions, we've got a little history, but how does it actually work? The article talks about two-stroke and four-stroke engines. Sounds like we're about to learn a new dance move.
More like the dance of the pistons, really. Imagine this. Every time a piston goes up and down in the cylinder, that's like a beat. Two-stroke is a quick two-beat rhythm, simpler, lighter, great for things like chainsaws, some motorcycles.
So two-stroke for quick bursts of power. Makes sense for those tools. But I'm guessing there's a downside, right? Otherwise, everything would be two-stroke.
Exactly. They're not as fuel efficient, and let's just say not the best for the environment. Now, four-stroke, that's more like a smooth four-beat rhythm. A bit more complex, but much cleaner, more fuel efficient, which is why it's the standard for most cars today.
Gotcha. More beats, smoother ride, less pollution. Makes sense. Okay, but how do those explosions even get started in the first place? I mean, it's all about ignition, right? The article mentions two main types, spark and compression. What's the difference?
It's a bit of a spark showdown. You've got your classic spark plug, common in gasoline engines. Simple idea, a spark jumps a gap, ignites the fuel-air mixture. But you'd be surprised how crucial the timing of that spark is for the engine to run smoothly.
So even something as small as a spark plug can make or break performance. What about compression ignition? That's diesel engines, right?
You got it. Diesel engines are all about ditching the spark plug altogether. They use the heat generated from compressing the air-fuel mixture to trigger the explosion. Super efficient, but, sometimes a bit stubborn to get going in the cold.
Yeah, that explains why my uncle's old diesel truck always had trouble starting in winter. Okay, so two ways to get the party started, but I gotta say, reading this article, I was surprised to learn gasoline isn't the only fuel ICEs can use. What's the deal with these alternative options? Natural gas, hydrogen, even biofuels.
Right. ICEs are surprisingly adaptable when it comes to what you put in the tank. We're talking natural gas, hydrogen, even biofuels made from plants.
So theoretically, you could be filling your tank with something that was once corn.
In theory, yeah, the technology is there. But it's not as simple as swapping out fuels. Think about the infrastructure, the cost. It's a whole different ballgame compared to good old gasoline.
So just because an ICE can use a fuel doesn't mean it's practical on a large scale. Makes you wonder then, what does this mean for the future of these engines?
The million-dollar question, and one we're definitely going to dig into. But first, let's talk about some other aspects of ICEs that might surprise you. Because it's not just about explosions and fuel, there's a whole lot more going on under the hood.
You know, we always talk about the fuel going into an engine, but it just occurred to me, with all those explosions happening, wouldn't the engine just melt itself from the heat?
It's a good thing you don't need a degree in thermodynamics to drive. But you're right, managing heat is a huge part of how engines work. All that combustion generates a ton of heat, like it's trying to turn itself into a molten mess.
Okay, that's a terrifying thought. So how do they stop that from happening?
Cooling systems, my friend. Most car engines use a mix of water and air to keep their cool. Basically, the water circulates through the engine, absorbs the heat, and then it's pumped through the radiator where the airflow cools it down. It's this constant loop, keeping everything at a safe temperature.
Like a delicate dance between fire and ice, huh? So we've got explosions, we've got cooling. But how does an ICE even start in the first place? It's like you need an explosion to get going, but don't you also need the engine running to create the explosion?
That, my friend, is where the humble starter motor comes in. That little electric motor that whirs to life when you turn the key or push the button, that gives the engine crankshaft, that initial spin it needs to start the whole four-stroke cycle: intake, compression, ignition, exhaust.
So the starter motor is like the jump start for the whole shebang, huh? Never really thought about it that way. Speaking of things I never really thought about, the article throws around terms like brake-specific fuel consumption and power band. Any chance you could break those down for us, mere mortals?
You bet. Those are all about measuring how well an engine performs. Brake-specific fuel consumption, or BSFC, tells you how much fuel an engine burns to make a certain amount of power. The lower that number is, the more fuel efficient the engine you're getting. More bang for your gallon, I guess you'd say.
So, lower BSFC, happier wallet at the gas station. Got it. What about power band? This sounds kind of rock and roll.
It's all about finding the engine sweet spot. It's the range of engine speeds measured in RPM where it's running at peak efficiency and power. Kind of like knowing the right gear to be in for optimal performance.
Like having a sixth sense for your engine. I like it. But we've also talked about different types of engines, like V8s, for example. Does the configuration of the engine, how it's all arranged, make a difference in how it performs?
Oh, absolutely. It's like engine architecture. The layout makes a huge difference. You mentioned V8's 8 cylinders in that iconic V shape, known for smooth power and that satisfying rumble, right? But there are tons of other configurations out there: inline engines, flat engines, even radial engines in some aircraft. Each one has its own quirks, its strengths and weaknesses that affect everything from how much power it puts out to how smoothly it runs, even how it sounds.
It's like engine design is a whole art form in itself, so it's not just about how many cylinders you cram in there, but how they all work together.
Fascinating. And I'm guessing all of this, the layout, the fuel efficiency, that power band sweet spot, it all ties into the big picture of how efficient an engine is overall, right?
Lingo.
Ungo. Automotive engineers, they're always on this quest for the perfect balance of power, efficiency, and of course these days, emissions. They use all kinds of tricks: clever designs, new materials, even super sophisticated computer controls. It's really remarkable how far things have come.
It's like squeezing every ounce of performance and efficiency out of these machines. And speaking of squeezing things out, we were talking earlier about alternative fuels for ICEs. But it seems like even with good old gasoline, there are still ways to make them more efficient, right?
Yeah, oh, absolutely. We're seeing some seriously cool innovations in that area. One of the big ones is variable compression ratio technology. Basically, these engines can actually adjust their compression ratio on the fly, optimizing for different driving conditions. It's like having an engine that can adapt to whatever you throw at it, highway cruising or city driving.
Wow, that's wild. So it's like the engine is always thinking ahead, trying to be as smart as possible about how it uses fuel. What other tricks do they have up their sleeves?
Well, another one that's becoming increasingly common is cylinder deactivation. Basically, the engine can shut off some of its cylinders when it doesn't need full power. Like when you're cruising on the highway, you don't need all 8 cylinders firing away, so it just takes a few offline for a while.
So it's like the engine is taking a little nap to save energy.
Exactly. It's all about maximizing efficiency wherever you can find it.
This is blowing my mind. It seems like even with traditional gasoline engines, there's still so much room for innovation. But I'm still curious about those alternative fuels. What do you do they have a real shot at becoming the norm? Or is it all just hype?
That's the million-dollar question, isn't it? And honestly, it's tough to say for sure. On the one hand, something like hydrogen, that's incredibly promising. An engine that runs on hydrogen, it could theoretically emit nothing but water vapor. Talk about clean energy.
That sounds incredible. But I have a feeling it's not that easy, or we'd all be driving hydrogen cars by now, right?
You're right, it's not that simple. While the tech is definitely there, the problem is scaling it up. Producing enough hydrogen, storing it safely, setting up the infrastructure for refueling, it's all massively expensive. And then there's the question of whether it'll ever be as cost-effective as gasoline or diesel.
So even if the technology is amazing, the logistics and the economics can still be a major roadblock. It seems like a recurring theme with ICEs. They're constantly evolving, but actually getting those advancements out into the world on a large scale, that's a whole other challenge.
It's true, and it's something that's important to keep in mind as we consider the future of this technology. And that brings us to another crucial aspect of the ICE discussion. its impact on the environment.
Yeah, the environmental impact, that's the big one, isn't it? I mean, we can talk about horsepower and efficiency all day long, but at the end of the day, ICEs have this reputation for being, well, kind of
See, it's
dirty.
the trade-off, right? Power and convenience, but at a cost. Internal combustion engines, especially those running on fossil fuels, they do contribute to air pollution, greenhouse gas emissions. It's something we can't just sweep under the rug.
And it's not just what's coming out at the tailpipe either. The article even mentioned noise pollution, like living near a busy road, that constant engine noise.
Oh, absolutely. That's a factor too. All those mini explosions, they don't just create power, they create noise pollution, which can be a real problem for communities and wildlife.
It's like this ripple effect, right? The impact of these engines goes way beyond just getting us from point A to point B.
Yeah.
Makes you think about the bigger picture. So, where does that leave us? With all these concerns, with electric vehicles getting so much attention, what's the future hold for the internal combustion engine?
The million-dollar question. If I had a crystal ball that could tell me that, I'd be a very rich man. But honestly, it's hard to say for sure. On the one hand, ICEs have been around for over a century. They're everywhere, and there's still so much innovation happening. But then you have this push for cleaner, more sustainable options, and electric vehicles are gaining ground fast.
It's like we're at a fork in the road, and both paths have their own set of challenges and opportunities. So, what do you think? Are we going to see a world where ICEs are just museum relics?
It's possible, but I wouldn't write them off just yet. Remember those innovations we were talking about, variable compression, cylinder deactivation? Those are making ICEs cleaner and more efficient.
Yeah.
And then there are even more radical ideas out there, like hydrogen combustion, which could be a game changer.
It's like instead of gasoline versus diesel or ICE versus electric, it's becoming more about finding the best solutions from all sides.
Exactly. We need to be open to all the possibilities. And that's what I found so fascinating about this whole topic. It's not just about the nuts and bolts of engines. It's about the future of transportation, the future of energy, and how we're going to power our world.
It's been a wild ride, that's for sure.
Yeah.
I thought I knew a thing or two about engines going into this, but I've learned so much.
That's the beauty of these deep dives, right? There's always something new to discover.
Absolutely. So, for anyone listening who's ever been curious about what makes their car go vroom, I hope this has given you a whole new appreciation for the engine under the hood, and maybe even sparked some thoughts about the future of transportation. A huge thanks to our expert for joining us today and sharing their incredible knowledge. And to all you listeners out there, thanks for hopping in the passenger seat for another deep dive. Until next time, keep those engines revving and those minds curious.